All right, 8.3. Let's do some definitions first. All right, so I am going to just refer to this diagram instead of writing down some definitions. So the first thing I'm going to do is just highlight this right here. Okay, so this would be the central angle. Let's see, this right here would be the intercepted arc. So that takes care of these two things. All right, let's talk about a radian now. So on 8.2, we talked about the degrees around the unit circle, sort of. We talked about values at the degrees. So now we're going to convert those degrees to radians. So when a central angle intercepts an arc that has the same length as the radius, then that's defined as 1 radian. So again, if the radius and the if the radius and the intercepted arc have the same measure, then that's equal to 1 radian. Now that probably doesn't make any sense, but that's okay. We'll get into some examples. Okay, and then to find the length of an intercepted arc, that's actually a formula. So the formula is going to be S equals R times theta. It's like a circle with a loop through it. It's called theta. R is the radius. Theta is radians. And S is the length. And I don't really need that picture, really. Okay, let's move on to the next page then. Okay, so we are going to write our measure in radians. Currently I have degrees. If I want to go from degrees to radians, then I am going to divide. Down here, I want degrees. I'm giving you radians. So if you're going to radians to degrees, you're going to multiply. So what you're going to do is, and this is done without a calculator, you're going to take 150 and divide by 180. I forgot to put divide by 180. That's key. Divide by 180. This one's multiplied by 180. And that can reduce. The zeros go away, and then 15/18 reduces to 5/6. And whenever I want radians, I just put a pi in the numerator. Okay, the next one is 40, so I'm going to divide that by 180. The zeros cancel, so 4/18, that's 2/9. And then I put a pi in the numerator. It's not radians unless you put a pi with it. Number 6, 160 divided by 180. The zeros cancel, and then 16/18 is 8/9. And then 220, I'm going to divide that by 180. The zeros cancel, 22/18 reduces to 11/9. All right, now let's go the opposite way. So again, I have radians this time, and I want, let me get this right, here we go. And I want degrees. This is a little blurry too. So I'm going to ignore the pi this time because I don't want pi in my degrees. So I'm going to multiply by 180. So when you multiply, you just multiply across, but again, I ignore the pi. So 180 divided by 6 turns out to be 30 degrees. Okay, so the next one I'm going to multiply by 180. And really I could cross cancel first instead of multiplying across, because again I can't use a calculator. So if I cross cancel, that becomes a 1, that becomes a 90. And again, I want to ignore the pi. 3 times 90 is 270. And these ones I can just ignore because 270 divided by 1 is just 270. All right, the next one, I'm going to multiply by 180. I ignore the pi. I'm going to get 180 divided by 9. That turns out to be 20 degrees. And then the last one, again, I multiply by 180. Ignore the pi. I can cross cancel again because I don't want to do 4 times 180. 3 goes into 3 one time. 3 goes into 180 60 times. And if I multiply straight across, I get 240. Okay, so there's that page. Let's go ahead and turn to the next page here. Okay, so on this page, it says to find the length of the indicated arc. So that means I need to use this formula right here. Now this time, this is calculator. So you need your calculator. And let's see, I'm going to cross off a few of these. I'll cross off 14 and 15 and 17, I guess. So all I have to do to find the length of the arc is take the radius, which is 19, and multiply it by theta, which is that. And then all I have to do is put that in my calculator, and I want to include the pi this time. So I'm going to put it in just like that, and we get 39.793. Oops, it's not degrees, it's centimeters. Okay, that's basically all you do. The next one, I'm going to take the radius times the radians, put that in my calculator. I get 2.094. This time my units are feet. Okay, I'm skipping 14 and 15 and 17 as well. Let's see, I'm checking something really quick. Okay, the last one, again, to find the arc length, I take the radius times the radians, put that in my calculator. And by the way, if you're not sure where the pi button is, it is right above the exponent button, so second exponent button. So my answer to 16 is 10.995. 10.995, and my units are inches. Okay, moving on. Okay, so on lesson 8.2 we made a table. So what I'm going to do is write it down. And if you recall, sine is the y value and cosine is the x value. Because what I need to do is find the exact values for cosine and sine. But these are in radians. So let's see here. I'm going to fill this in. So sine at 0 is 0. And then it's 1/2 root 2 over 2, root 3 over 2, and then 1. If I know those, cosine is the exact same thing but flipped. Okay, now these three right here, 30, 45, and 60. On the unit circle, actually let's look at the last page really quick. Let's just look at the first quadrant, which is right here. So this is 0, 30, 45, 60, and 90. That's the table that I wrote down so far. Okay, so let's try to do the radians. So I got 0 pi. So if I want radians here, I want to go from degrees to radians. So I'm going to divide. So 30 divided by 180 is 1/6. So pi over 6. And we can use a calculator to just this time. So let's see, 45 divided by 180, that's 1/4, so it's pi over 4. 60 divided by 180, that's 1/3, so it's pi over 3. And then 90 divided by 180 is 1/2, so that's pi over 2. Okay, let's go back to this page now. So I can already, well, let's write them on here now, so I'll keep flipping back and forth. So this is 0 pi. This is pi over 6, pi over 4, pi over 3, and pi over 2. Okay, well, this one's already on there. So pi over 4, sine and cosine both are root 2 over 2. I'm going to write them as an ordered pair. Now remember, cosine is x and sine is y. The table's backwards, but on this one it doesn't really matter because they're the same value anyway. Okay, let's do 21 next because it's also on my table. So my values are 1 and 0, 0 for cosine, 1 for sine. So there's my answer to that one. Now the rest aren't on this table, but it is on the unit circle. So let's look at it this way. If my denominator is 3, then it's going to be this ordered pair. Let me go ahead and write that down. Let's see, 1/2 root 3 over 2. Now I have to come back to this one because I'm not in the first quadrant anymore. So one of these is going to have to be negative. Okay, this one has a denominator of a 6, so it has to be this ordered pair. Again, I have to come back to that one. This one also has a denominator of a 6, so it's going to be the same numbers as we wrote down for 22. And this one has a denominator of 3, so it's going to be the same one we wrote down for this one. But again, I have to go back and look to see what the signs are. Okay, let's think about this one for a second. So my denominator is a 3. That means it's a multiple of 60. All I have to do is take 60 times the numerator. So 60 times 2 is 120. This is the same thing as 120 degrees. Okay, let's do this one then. My denominator is a 3. That means it's a multiple of 60. Multiply it by the denominator. 60 times 5 is 300 degrees. Okay, these are both a denominator of a 6. If it's a denominator of a 6, it's a multiple of 30. So multiply 30 by the numerator. That's 210 degrees. 11 times 30 would be 330 degrees. Okay, so now if I go back and think about all these from 8-2, I can then figure out where these are going to fall. So 120 is going to be in the second quadrant. In the second quadrant, the x value is negative and the y value is positive. 210, that's in the third quadrant. Both x and y are negative in the third quadrant. This one's 330. That's going to be in the fourth quadrant. In the fourth quadrant, the x value is positive and the y value is negative. I think I skipped one. These are both in the fourth quadrant. So the x values are positive and the y values are negative. Okay, now let's go to our unit circle now on the back. Eventually you're going to have to memorize this unit circle. So what I'm going to remind you of, because I have said this before, the unit circle is just a bunch of patterns. So what I'm going to do, if you notice here, the bigger section, you're going to add 30. The smaller sections, you're going to add 15, and the bigger section, you're going to add 30. So it goes 30, 15, 15, 30, repeat. 30, 15, 15, 30, repeat. So on 90, if I add 30, I get 120. Add 15, it's 135. Add 15 again, that's 150. Add 30, that's 180. Okay, repeat. Add 30, 210. Add 15, 225. Add 15 again, that's 240. Add 30, that's 270. Repeat. Add 30, 300. Add 15, that's 315. Add 15 again, that's 330. Add 60, 360. So those are all the degrees. Okay, now let's go through and do all the radians. And again, there's patterns. So the ones that are closest to the y-axis, those are all going to have a denominator of a 3. So this is pi over 3. This one's pi over 3, and this one's pi over 3. The ones in the middle are going to be pi over 4. And the ones closest to the x-axis are going to be pi over 6. Okay, now let's do the numerator. And again, there's patterns everywhere. So in the second quadrant, the numerator is always 1 less than the denominator. And don't forget to put a pi there. In the third quadrant, the numerator is 1 more than the denominator, and you've got to put a pi with it. Okay, denominator. We're going to do 2 times the denominator minus 1. So 3 times 2 minus 1 is 5 pi over 3. 4 times 2 minus 1, that's 7 pi over 4. 6 times 2 minus 1, that's 11 pi over 6. Now we have these that are on the x and the y axis. I already have that one. I don't have this one yet. I don't have this one yet. So if this is a half pi, this must be 1 pi. So I'm counting by halves. So this is 1/2, 1. 1.5 would be 3 pi over 2. And this would be 2 pi. So again, there are patterns everywhere. So you just have to make sure you memorize this eventually. It'll take some practice. Now you should be able to do the 8-3 homework. This unit circle will help you.